Tesla CEO Elon Musk has done it again, but what exactly is he up to this time? Can a single part of a car truly shake the entire electric vehicle industry? Musk just revealed a revolutionary motor that completely eliminates the need for rare earth metals. So, how will this change the game for production, costs, and supply chains worldwide? Could this be the breakthrough that forces every other automaker to rethink their entire strategy? What hidden engineering secrets make this motor smarter, lighter, and more efficient than anything we've seen before? So why does this new Tesla motor actually matter? At first glance, a motor might seem like just another part of a car, but in an electric vehicle, it's the beating heart. Without a powerful, efficient motor, even the best battery can't deliver speed, smoothness, or range. This is exactly where Elon Musk is shaking things up. By removing rare earth metals from the equation, he's not just tweaking performance. He's redesigning the foundation of how EVs are built, and the implications go far beyond a single car model. Rare earth elements like neodymium have long been the secret sauce for powerful compact motors. They allow motors to produce intense magnetic fields in a small space, giving the car the kind of instant torque and efficiency that makes EVs feel futuristic. But there's a catch. These materials are rare for a reason. Mining them is expensive, environmentally destructive, and concentrated in only a few countries, mainly China. That has left the global EV industry exposed to political risks, volatile prices, and supply bottlenecks. By announcing a motor that eliminates rare earth metals, Elon Musk is not just innovating technically, he's also tackling a major geopolitical and economic challenge. Experts are already buzzing. Some are calling it a bold bet because replacing rare earth metals without compromising performance is a huge engineering challenge. The key lies in Tesla's ability to combine clever materials with advanced software. Instead of relying solely on the raw strength of neodymium, Tesla's new design uses sophisticated algorithms and smart motor architecture to control the flow of electricity and magnetic fields. Sensors constantly monitor torque, speed, and load, adjusting the motor's behavior in real time. The result? A motor that responds instantly, runs smoothly, uses less energy, and requires less cooling without relying on rare earth magnets. This also has major implications for scale and sustainability. Removing rare earth dependence makes it easier for Tesla to produce millions of vehicles around the world without worrying about shortages or skyrocketing costs. It also reduces the environmental impact associated with mining and processing neodymium. Musk's vision seems clear. EVs shouldn't just be fast or luxurious. They should also be ethical, sustainable, and accessible to a global market. But here's the question that keeps competitors awake at night. Can this rare earth-free motor truly match or exceed the performance of traditional designs at scale? And if Tesla succeeds, how long before other automakers have no choice but to follow suit? This leads us to the next part of the story. The engineering and material secrets inside Musk's new motor that make it so powerful and efficient, even without rare earth metals. A quiet revolution in motion that could redefine the EV industry. When Elon Musk announced Tesla's new rare earth-free motor, he wasn't just talking about innovation, he was pointing directly at a major vulnerability in the EV industry. Rare earth metals like neodymium, dysprosium, and terbium have powered electric motors for years because they're insanely strong magnets in tiny packages. But strength comes at a price, and not just in dollars. Mining these metals is a complex, expensive, and environmentally risky process. For the global EV supply chain, this has been a hidden time bomb. Think about it. Almost all neodymium comes from just a handful of countries, with China dominating production. That creates massive geopolitical risks. Any shift in trade policies, export controls, or international tensions could instantly ripple through the EV market. Imagine Tesla suddenly struggling to source enough magnets for millions of vehicles. Prices spike, production slows, and suddenly, what seemed like a futuristic industry starts looking fragile. Musk has clearly seen this problem coming, and it seems he decided that instead of relying on a shaky supply chain, Tesla needed a smarter, more sustainable solution. Environmental concerns make rare earth dependence even messier. Extracting these metals isn't like digging up coal. It involves massive chemical processing, enormous water usage, and toxic waste that can devastate local ecosystems. Communities near mining sites often suffer from pollution and health risks, and governments are under pressure to regulate these practices more strictly. For an industry that markets itself as green and sustainable, this is a glaring contradiction. Musk must have realized that if EVs are truly going to scale worldwide, relying on rare and destructive materials is a dead end. Experts have been talking about this problem for years. Some predicted that the rare earth bottleneck could slow down the EV revolution, limiting production and inflating costs. Others warned of political leverage, where a single country could hold the industry hostage. By targeting a motor design that eliminates these metals, Musk isn't just addressing a technical challenge, he's strategically future-proofing Tesla and potentially rewriting the rules for the entire industry. But there's another twist. Removing rare earth magnets isn't simple. Their magnetic strength is hard to replicate, meaning Tesla had to rethink the physics of the motor itself. That's why the new motor isn't just a mechanical component. It's a blend of smart materials, software, and innovative architecture. Musk isn't just cutting costs or avoiding supply risks. He's proving that EVs can be more efficient, sustainable, and powerful without depending on politically sensitive and environmentally damaging resources. The real question now is, if Tesla can pull this off, how long before the rest of the EV world has no choice but to follow? And what does this mean for the future of electric vehicles as a whole? Next, we'll dive into the engineering secrets that make Tesla's rare earth-free motor not just possible, but potentially superior to anything on the road today. When Elon Musk unveiled Tesla's new motor that completely skips rare earth metals, the EV world sat up straight. This isn't just a tweak to an existing design. It's a full rethink of what an electric motor can be. For years, engineers believed that powerful magnets made from rare earth elements were indispensable. But Tesla is showing that with clever design and advanced materials, it's possible to get the same, or even better, performance without them. So, how did Tesla do it? The key lies in materials like ferrite and ceramic magnets. These aren't rare, costly, or politically sensitive. They're common, stable, and far more sustainable. The trick, though, isn't just swapping materials. Ferrite magnets are weaker than neodymium, which means a motor built around them has to be engineered differently. Tesla's engineers solved this with a combination of precise magnet placement, optimized coil structures, and software that actively manages torque and efficiency. Essentially, the motor isn't just spinning, it's thinking. This approach is significant for several reasons. First, it dramatically reduces reliance on volatile supply chains. Tesla can now source materials from multiple regions without worrying about political bottlenecks or monopolies. Second, it makes production cleaner and more environmentally friendly. Unlike rare earth mining, ferrite and ceramic production doesn't produce toxic waste on the same scale, which aligns perfectly with Tesla's mission of sustainable innovation. And third, it opens the door to scaling EV production faster, with less risk and lower costs, without compromising performance. Industry experts are paying close attention. Analysts note that if Tesla can mass-produce these motors without losing efficiency, it will force competitors to rethink their powertrain strategies. Ford, Volkswagen, and GM, all heavily invested in rare earth-dependent motors, could find themselves in a tricky position. Tesla's move isn't just a technical adjustment. It's a strategic play that touches everything from pricing and supply chains to environmental impact and global competitiveness. But here's where it gets even more interesting. The motor itself is smarter than many people realize. With embedded sensors and real-time algorithms, Tesla's system can adjust current and magnetic fields dynamically. That means even weaker magnets can deliver strong torque when needed, without wasting energy at cruising speeds. It's a motor that adapts, optimizes, and maximizes efficiency on the fly. The question now is, how quickly will Tesla integrate this across its lineup, and will it spark a wider industry shift? This innovation isn't just about making one model better. It's about redefining what EV motors can be. And while the public sees a quieter, more efficient drive, under the hood, a revolution is quietly spinning. Next, We'll dig into the engineering behind Tesla's motor magic and see why this rare earth-free design might outperform even the strongest traditional setups. When Elon Musk revealed Tesla's rare earth-free motor, many were curious about one thing: how does it actually work? This isn't just swapping one type of magnet for another. Tesla has completely reimagined the way an electric motor functions, blending clever engineering with smart software to get performance that rivals, and in some ways beats, traditional rare earth designs. At its core, the motor relies on ferrite and ceramic magnets, which are weaker than neodymium. That presents a challenge. Weaker magnets usually mean less torque and slower response. But Tesla's engineers didn't just accept that limitation. They turned it into an opportunity. They redesigned the internal architecture of the motor, placing magnets at precise angles, optimizing the winding patterns of the coils, and ensuring that every joule of electricity is used efficiently. It's like rearranging a puzzle so that the pieces fit perfectly, extracting maximum performance from a resource that was previously considered less powerful. Then comes the secret sauce: software. This motor isn't just spinning, it's thinking. Real-time sensors track every movement, current flow, and magnetic interaction. Algorithms adjust the field dynamically, giving extra torque when needed, or switching to efficiency mode on highways to conserve battery. That means even with magnets that are weaker on paper, the car accelerates smoothly, responds instantly, and maintains impressive efficiency. Essentially, Tesla turned a physical limitation into a digital advantage. Why does this matter now? Because EVs are moving from niche luxury items to mass-market vehicles. Scaling production without relying on rare earth metals removes both cost and supply chain risk. It also positions Tesla ahead of competitors, who still rely heavily on scarce materials. Analysts suggest that any automaker that doesn't innovate in motor design now could face significant challenges in the next few years, from rising costs to production bottlenecks. Experts are already talking about it. Dr. Amanda Reyes, Tesla's head of powertrain engineering, hinted that this motor platform is scalable across Tesla's lineup, from the affordable Model 3 to the high-performance Plaid versions. That means the same engineering principles could eventually power millions of vehicles worldwide, all without the political and environmental headaches of rare earth sourcing. But the most fascinating part? The motor is designed to keep learning. With software updates, Tesla can tweak performance remotely, improving torque curves, efficiency, and even heat management over time. It's a motor that evolves, rather than one fixed at the factory. Next, we'll explore how this innovation could completely reshape the global EV market, and why competitors may be forced to rethink everything from design to supply chains. When Elon Musk announced Tesla's rare earth-free motor, the big question on everyone's mind was, how does this benefit us, the drivers? It's more than just a technical headline. It's a shift that could change everything from cost to reliability and even environmental impact. First, let's talk about Tesla itself. Removing rare earth metals drastically reduces dependency on volatile supply chains. Neodymium and other rare earth elements are mostly mined in a few countries, with China leading the pack. Any disruption there can spike costs and slow production. By switching to ferrite and ceramic magnets, Tesla lowers material costs and secures a more stable supply. That means the company can scale production faster, without worrying about political tensions or resource scarcity. And for investors, it's a clear signal. Tesla is preparing for the future, not just reacting to the present. For EV buyers, the benefits are just as tangible. Because the motor is lighter and more efficient, cars require less energy to operate, which directly improves range. You could be driving longer distances between charges without noticing any drop in performance. Maintenance is another upside. Traditional motors with rare earth magnets often need more careful handling and can generate excess heat, wearing out faster over time. Tesla's new design reduces friction, heat, and stress on components, meaning fewer trips to the garage and lower lifetime costs. Then there's the environmental side. Mining rare earth elements isn't just expensive, it's environmentally damaging. Toxic waste, massive water usage, and land disruption are all part of the package. Switching to more common, environmentally friendly magnets reduces Tesla's ecological footprint, aligning with Musk's vision for sustainable energy. For the eco-conscious driver, this isn't just a technical improvement. It's a statement about the kind of future you're choosing to be part of. Competitors are watching closely. Analysts predict that Tesla's ability to cut costs while boosting performance could force other EV manufacturers to rethink their entire motor design strategy. It's not just about speed or luxury anymore. Efficiency, sustainability, and resilience are becoming core selling points. And here's the kicker. This isn't limited to high-end models. Musk's strategy is scalable across the entire lineup, from the affordable Model 3 to the futuristic Cybertruck. That means these benefits, cost savings, improved range, lower maintenance, and sustainability could be available to millions of drivers worldwide, not just a niche market. But the story doesn't end here. Tesla's rare earth-free motor isn't just about today's cars. It's setting the stage for autonomous fleets and next-generation vehicles. Up next, we'll explore how this innovation could shake the global EV market and force other automakers to rethink their strategies. When Elon Musk unveiled Tesla's rare earth-free motor, it wasn't just a company announcement, it was a signal to the entire EV industry. Suddenly, a technology that was once considered a small detail has become a central battleground. How will competitors respond when Tesla can produce powerful, efficient motors without relying on scarce and expensive materials? That's the question everyone is asking. For decades, the global EV industry has been tied to rare earth elements. Neodymium, dysprosium, and similar metals have been essential for high-performance motors, but supply is concentrated in a few countries. Any disruption, a geopolitical conflict, trade restrictions, or sudden price spike can ripple through the entire sector. Musk's move effectively breaks that chain, giving Tesla a major strategic advantage while forcing others to rethink their production plans. Analysts are already speculating on the consequences. Companies like Volkswagen, GM, and BYD, which invested heavily in rare earth motor technology, now face tough decisions. Do they continue with existing designs and risk higher costs, or do they accelerate research into alternative magnet technologies? Either choice carries financial and technological risks. Musk has essentially set a new benchmark, showing that it's possible to maintain power, efficiency, and reliability while eliminating rare earth dependency. This shift also has implications for vehicle pricing. Tesla can reduce manufacturing costs, which might allow lower prices for buyers or higher profit margins. For competitors, maintaining margins without rare earth-free alternatives becomes a challenge, and that pressure could reshape market dynamics worldwide. Investors are watching closely. Companies that don't adapt could fall behind in what's now a rapidly evolving landscape. There's also an environmental angle that can't be ignored. Rare earth mining has long been criticized for ecological damage. By moving away from these metals, Tesla positions itself as not just a technological leader but also a sustainable one. This adds a new layer of competition. It's no longer enough to offer speed or luxury. Buyers are increasingly weighing ethics, sustainability, and long-term viability when choosing an EV. And let's not forget future mobility. Musk has repeatedly emphasized autonomous fleets and large-scale EV adoption. If millions of vehicles are deployed worldwide, relying on rare earth metals could become logistically and politically risky. Tesla's new motor design isn't just a product improvement. It's a strategy to make large-scale, sustainable EV production feasible and scalable. But the real question is, can other automakers catch up? Or will Tesla's rare earth-free motor create a gap that lasts for years? The industry is on the brink of a major transformation, and the next chapter will reveal what this could mean for drivers, investors, and the future of mobility. Elon Musk's announcement of Tesla's rare earth-free motor isn't just a technical innovation. It has major environmental and geopolitical implications. For years, the EV industry has relied on rare earth metals like neodymium and dysprosium, which are essential for high-performance motors. But mining these metals comes with serious environmental costs. Extracting them requires large amounts of water, chemicals, and energy, often leaving toxic waste and damaged landscapes behind. By moving away from rare earth materials, Tesla is reducing its environmental footprint, signaling a future where electric cars aren't just cleaner on the road. They're cleaner from the ground up. Geopolitically, the implications are just as significant. China currently dominates the production and export of rare earth metals. Any supply disruption, from trade tensions, export controls, or political decisions, can impact automakers worldwide. Musk's strategy to eliminate reliance on these metals not only shields Tesla from these risks, but also challenges the existing power dynamics in global EV supply chains. Suddenly, the industry has to consider not just performance and cost, but political vulnerability as well. For other automakers, this is a wake-up call. Companies that continue to depend heavily on rare earth magnets could face production bottlenecks, higher prices, and increased exposure to international disputes. Investors and analysts are already weighing how Musk's move could reshape competitive advantage in EV markets. Beyond economics, Tesla's approach also raises expectations for sustainability. Consumers are increasingly conscious of the environmental cost of the products they buy. By introducing motors that avoid ecologically damaging materials, Tesla positions itself as both a technological and ethical leader. This development could also accelerate research into alternative materials, such as ferrite or ceramic magnets, across the industry. But Tesla has the advantage of combining innovative materials with advanced software and motor design, making their solution scalable without compromising efficiency. Musk has made it clear, the goal isn't just to build faster or cheaper EVs, it's to build a sustainable and globally resilient EV ecosystem. As governments, automakers, and environmental groups react to this shift, one thing is certain: Musk's rare earth-free motor could change how the world thinks about electric vehicles, not just as transportation, but as a strategic and environmental priority. And this leads directly to the next question. How will this motor impact Tesla's future production and global market expansion? Elon Musk has once again reminded the world that innovation doesn't always need loud announcements or flashy launches. Sometimes, it's a quiet revolution happening under the hood. Tesla's new rare earth-free motor is more than just a clever engineering feat. It's a statement about the future of electric vehicles, sustainability, and global supply chains. Musk's vision shows that real change often starts by rethinking the basics. In this case, the very motor that powers EVs. By removing reliance on rare earth metals, Tesla isn't just solving a technical problem, it's addressing environmental concerns, supply chain vulnerabilities, and even geopolitical risks that have long shaped the auto industry. For Tesla, this move strengthens their position in the market. Fewer dependencies on scarce resources mean lower production costs, more consistent supply, and greater freedom to scale vehicles worldwide. For buyers, it translates into cars that are more affordable, reliable, and aligned with a greener future. And for competitors, it's a clear signal. The bar for innovation is no longer just speed, range, or luxury. It's sustainability and smart engineering working hand in hand. Analysts are already predicting that this motor could influence how every automaker approaches EV design in the coming years, pushing the industry towards smarter, more ethical production choices. But the story doesn't end here. Musk's announcement hints at broader ambitions. Motors that rely on intelligent design and software, not just powerful materials, could redefine performance expectations for EVs. This quiet shift may not make headlines immediately, but its impact could ripple across the market for decades, shaping which companies thrive and which struggle. Tesla's approach demonstrates that innovation isn't always about doing something flashy. It's about doing the fundamentals in a better, smarter, and more sustainable way. So, as Tesla rolls out this rare earth-free motor across its lineup, the world is watching closely. Every Model 3, every upcoming Model 2, every future vehicle quietly carries forward Musk's vision. And while the motor itself may spin silently, the revolution it represents is far from quiet. The real question now is, how will the rest of the industry respond? And who will be able to keep up with Musk's quiet, unstoppable innovation?